Okay, so today we're going to talk about data visualization. To preface this section, for data visualizations, what's most important is that you're able to make visualizations that are meaningful. You don't have to be very well versed in, and I know in our curriculum we talk about both Matplotlib and Seaborn. Actually, Seaborn is built off of Matplotlib to basically simplify some of the methods in Matplotlib. You don't have to know both. So my advice, and some people take this advice, some people actually prefer the flexibility of, if the data is this specific way, I know I can use this method. But you can definitely just focus on one, whichever one is more comfortable. Basically, between Matplotlib and Seaborn, Matplotlib, you have a lot more customizability. It's a lot more like atomic, and I'll walk through what I mean by that later. And then Seaborn, a lot of it is pre-built. The colors are also nicer by default. So it's kind of up to you which one you want to pick and choose. And for like the project at the end of phase, and also the mini projects, it doesn't matter which library you use. In this study group, I'll also be introducing another library, and that's a library I actually learned on. I'll show you why I like it more. But yeah, just know that you don't have to be very familiar with both or all three visualization libraries. One more thing that I want to preface this section with is every time I need to make a visualization that's more complicated than like a single like chart, I always have to look it up. Syntax, I think, for visualizations is one of the most complicated, and not complicated, but there's just a lot of syntax to remember. And a lot of the arguments, they're also kind of inconsistent. So if you find that, some of the things are just not sticking, that's okay. I think it's a matter of just getting used to reading the documentation and getting used to, the process of figuring out how to get the chart that you want. All right, but to get started, why do we make visualizations? Some people would argue that, you can get a lot of the same information just by looking at the data frame itself. Right? Like you can do like the .describe, you can do the .info, and you can pretty much get like summary statistics, kind of similar to what you would get off of a visualization. I just think that this is a funny one. If anyone has heard of, if you saw that dinosaur, it's called the Datasaurus dozen. Let me zoom in a little bit. I think this is funny. So there's this data set that it's a scatter plot of like X and Y, and it makes this dinosaur shape. And this dinosaur shape has these overall statistics. If you take the mean X value, it's 54.26. The mean Y value is 47.83. All of these other like metrics are X and Y. So what's kind of funny is that all of these 12 other visualizations have the exact same overall statistics. And that I think just goes to show that, it's important to visualize your data, because sometimes if you like just look at mean and standard deviation, yes, you can understand more about the distribution of your data, but you might not get nuances like this, because every time you're taking like an overall statistic or you're doing some sort of aggregation, you lose information, you lose a dimension of data. By that, I mean, like, you have a range of X values, and you're representing a range of values as like one number for mean and one number for standard deviation. And so it's because of that aggregation that's happening, you lose information. And that's where visualizations come in handy, because it's just like without a visualization, I think just looking at like even a list of like, 20 numbers is not as easy to figure out, okay, how is it really distributed? And then with the help of mean and standard deviation, yes, you can figure out more about the distribution of your data, but you might not get nuances like this. That's like my big like why visualizations are important. As another fun fact, I last year was on Glassdoor, just like curious of like data science jobs for like my students, and I found that there is actually a position called data visualization consultant, which I'd like looked up, and their job is to really just consult on the kinds of graphs used in presentations. And they get paid very, very well, which I was kind of like slightly irked by, because like they don't do like machine learning, but they still get paid very, 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 very decently. So I just thought that was like interesting to know that, there's a lot of, and And going into visualization, there's so much that goes into it. It's not just like, can you make this graph? But on a deeper level, if you ever are interested in like, you know, putting together like dashboards or like any sort of platform where you have multiple visualizations, there's a lot that goes into it. Like to some degree, there's a lot of like user experience design. There's also a little bit of psychology and like how people absorb information. We're unfortunately not going to get into much of it in this program because visualizations are, for our purposes, more of, you know, and I'll talk about how we use them, but yeah, there's a lot that can go into visualization. If this is something that you really like, just know that there's a career path for you. All right, so how do data scientists use visualizations? I think it's important to use this as a primer as to like, you know, why our visualizations are and what they're used for. Two main aspects. One as exploratory data analysis. So EDA, exploratory data analysis, is something that we're going to be doing for all our projects. It's basically when you get a giant data set and you don't know what to make of it, you will use visualizations along with, you know, df.info, df.describe to learn about your data. So the two things here: to explore the data that we have, find out more about what we're working with, and also try to look for patterns and relationships. It's just, you know, the main point of an EDA is to understand your data better so that when you get into like the modeling phase or when you get into like, you know, making recommendations, you know, you understand your data as much as you can. The second way that we use visualization is for explanatory data visualizations. And this is really for stakeholders, depending on how broad the scope of your data science project is. It might be explanatory data visualization to help to like explain your model, explain how you arrived at this conclusion. The difference here is like who the audience is. With EDA, the audience is usually yourself or whoever wants to understand like the raw data. But for explanatory data, for explanatory visualizations, the audience is usually some stakeholder because you want to kind of, you know, explain why you're recommending that a business does this. And yeah, to convey your narrative, your takeaways, your insights. As a preview, our end of phase one project is going to be a set of explanatory data visualizations. We're not going to get into any modeling in this phase. So if you take a look at our project, the project is basically to create, I forget how many, I think it's like 4 or 5 explanatory visualizations to further recommendations to a company. And we'll talk about that when we get there. So that's the context for visualizations. And this notebook is structured in 3 parts, just talking about the 3 visualization libraries. And then under each one, I'll focus in on like a specific thing. So first, we're going to start with Matplotlib. For Matplotlib, this is the default import statement. So it's matplotlib.pyplot as PLT. You might see versions that are like import or like from Matplotlib import pyplot as PLT. So basically why you might see different versions of this, and this is definitely the default one. Basically Matplotlib, imagine it as like folders. Matplotlib is a giant folder. Nested in Matplotlib, there's a pyplot folder, and that folder is where we're using all of our plotting methods. I don't think I have even used anything outside of the pyplot folder. So yeah, just so you know why like it looks like this, because you can import Matplotlib by itself, but the difference will be every time you want to like use something like this, you would have to do pyplot dot whatever, like matplotlib.pyplot.scatter, for example. That's basically like a little bit about like how libraries are structured. But this is the default import statement. This Matplotlib inline. So whenever you see like a % sign, it's called a magic function. I have not done like enough like backend research to see like what exactly this means, but this basically allows it allows your graphs to render nicely in a notebook. So just inline in your notebook. And then of course we have our NumPy and Pandas because that's what we're going to use. Cool. So let's import these. And we're going to use that same car data set just as like examples for visualization. So if you remember, these are our columns. So I linked the documentation to Matplotlib here. And this is just a list of the most common visualizations. And then I'll talk about like how you would structure plotting a Matplotlib plot. So by default, if you do plot plt.plot, it gives you a line plot. So just an example, if I do plt.plot and then let's plot like one of the columns, let's maybe do like, I don't know, weight, RDF weight. It's not going to look pretty, I think. Yeah, because it's going to go in chronological order, or it's going to go in index order, but there we have a line plot. As you can see, there's not much to this plot. It's literally just like the numbers here. They're not even labeled. So by default, when you do a plt dot something without any of these other things, which I'll talk about how these are working in a bit, it just comes out as a plain graph. So there's dot plot. There's also dot, I wonder what dot bar will look like with this kind of data. Yeah, let's do car DF. Oh, actually, that won't work. That's not a good kind of data. Another one, I wonder if there's plot.histogram. Let's see. And I bring up histogram because, there we go. Histograms and bar graphs. Does anyone know the difference between a histogram and a bar graph? I don't know. Any thoughts here?
Go ahead.
No, go ahead, Nelson.
I was going to say the histogram counts frequencies and categorical data, whereas what is it? The bar graph has the, I guess, weights towards everything. So like your x values is, well, your x line or axis is a value, and so is the y based on those x values.
Similar. So let me see if I can get an example of a bar graph. Maybe not weight, but let's use, I wonder if cylinders will work. Okay, so let me do cylinders. Okay, so cylinders look like this as a histogram. If I do plot.bar, I wonder if this will work. Cylinders. How do I plot a bar? So basically, yeah, I would want to count up this. Anyways, you're very close. So the difference between a histogram and a bar graph is that histograms are for continuous data. So they both count frequencies, just that for a histogram, it's for continuous data. And for a bar graph, it is discrete data or categorical data. So for example, this, it's kind of like a gray area here, because cylinders, I know that the values are like 3, 4, 5, 6, and 8. And then under 3, there's like, I don't know, less than 10. Under 4, there's like 200 cars with 4. The bar graph would look almost exactly like this. For a histogram, usually for a histogram, the bars are adjacent to each other. They're kind of connected to each other, like what this one looks like in weight. Is it not weight? Wait. Oh, I wanted to do histogram. Okay. So it would look like this. If I wanted to turn this into a bar graph, I would actually have to define bins. So for example, I would say, okay, I need to have 1 bar for every car, for cars between like 1,000 to 2,000, 1 bar for 2,000 to 3,000, and then the bars would be a little bit more discrete. It's a very, very subtle difference, but just, what's the word? Officially? No, technically, by definition, histograms are for continuous variables, and then bar graphs are for discrete or categorical variables. All right, yeah, these are just some like of the most common ones. I should add histogram to this list because histogram is one of the more common ones too. Okay, so building up on Matplotlib, as you can see here, again, I mentioned that, you know, there's no labels, there's no title, there's no like legend. So let's just use this as our next example. So the next example that we have here is a scatter plot, and a scatter plot will basically show the relationship between 2 variables. You can also have a 3D scatter plot to show the relationship between 3, but those sometimes are a little bit harder to look at. So here I have this scatter plot looking at displacement versus horsepower. I only know this because I'm telling it to plot displacement and horsepower. If I just have this graph, I have no idea what it is. So the way that Matplotlib works, it's actually built off of like object-oriented programming. If anyone is familiar with that, if not, we'll actually get to that in phase 3. So not to worry too much about now. But when you do a plot.scatter, what it does is it just on a blank canvas plots the graph. Anything that you want to add to it, it's sort of like adding things to a painting. And so that's why when you do like plt.title, let me just uncomment these one at a time. Oh, by the way, the shortcut to comment and uncomment is Control ? If you don't know that yet. So when I uncomment this line and I add a title, you can see here, I've added a title. And Matplotlib plots usually are a lot of lines because the more things that you have on a graph, you're just like adding more and more things to a painting. And then you just have to add line by line. And so officially, I'm blanking on the word right now, but PLT is the plotting library. And then each of these, they're sort of like attributes or methods that add the thing that you want to add. And so I always forget, like these are things that I don't remember off the top of my head. And I'll show you when it gets a little more complicated with subplots. But usually I'll look up, okay, how do I add like an X label to a figure? And then I looked it up. It is plt.xlabel. And then one by one, it just adds the thing that I want to add. So you can see here, I've added displacement. When I uncomment this, I've added horsepower. Maybe I want to add a legend. Here you can see like the legend, each blue dot refers to a car. And then this last one, plot.show, does that. What does the plot.show actually do? If I uncomment this, you can see here that it outputs this object. This kind of looks familiar maybe, because remember when we were dealing with like filter lambdas and map lambdas, if we don't coerce into a list, this kind of thing shows up. It just tells you like, okay, what is this object or what is this data thing at this address in memory? So this is actually where in our computer's memory, this graph is being saved. And then plot.show, if I undo that, you can see that there's no output. And then that object thing doesn't show up. So it actually kind of has to do with the fact that, you know, in Jupyter Notebook, it automatically outputs or executes whatever the last line is. So plot.show will just output plot.show. When plot.show is commented, the last thing in the cell is plot.legend. So it's actually trying to output plot.legend. And because it knows that plot.legend is part of this plot, that's why it, one, outputs this. But then within each of these, you can sort of think of it, and if this is more confusing, don't worry about it. Each of these lines actually sort of has embedded like a print statement, which is why the graph always shows up. If that doesn't make sense, it's actually not that important. But it's good practice to, at the end of a graph, have plot.show. So the main thing I want you all to take away from this is that, you know, when you're adding elements to a graph in Matplotlib, it is like element by element. You're adding one thing at a time. And all of the different things that you can do, all in the documentation. It's usually, it's like, all right, what is my graph missing? If I'm missing like a label here, maybe I want to change it. And if I don't want this to show like in increments of 50, like 50, 100, 150, there's an argument that can adjust that. I don't know what it is off the top of my head either. So that's Matplotlib as like for like a one graph Matplotlib. Where I think it got really confusing, especially in the pre-work, was when you got to subplots. So subplots is basically like when you want to have multiple graphs in a figure. So I'm just going to run this example real quick. This is just a histogram of like, it's just two histograms side by side of my weight and my year. And I'm going to talk about what's going on over here. There are different syntaxes for doing subplots. I think this is probably the most common one. You might see one that's also like add subplot and it's like 1, 2, 1 and 1, 2, 2. That is, it's kind of similar. I think this is the slightly easier way to go about it. So as you can see here, it's a little bit confusing, but you're defining two variables at the same time. You're defining a figure and an axis. I'll go into the documentation and explain why it's this way in a little bit. But a figure basically refers to the entire space. The entire image that is output, that's my figure. And then axes are basically where data is plotted. Each subplot is an axis. And why you have to have two variables there, we go into the documentation. So you can see here, this is the documentation for subplots. You can give it like number of rows, number of columns. You can give it all these other variables, all these other arguments, sorry. And it returns two things. So a lot of the functions and methods that we've been working with so far, they return one thing, but here they return two things, fig and an ax. So what exactly is going on when you return two things? The whole idea behind this is unpacking. If you remember when we were like unpacking those like lists of tuples for dictionaries, if that doesn't make sense, it's okay. We're going to talk about it right now. So as a quick example, so plt.subplots, and let's just use like a different one. Let's just do like 2 as an example. So plt.subplots. If I just do that, if I just define that and do nothing else, this is what is output. So you can see there's like, because I did 2 by 2, which is basically means like I want 2 rows, 2 columns. If I do nothing, you can see, great, I have 4 empty graphs. So at least I know I have it laid out right. Also here, it outputs these. So here you can see it's actually a tuple. This is a little bit hard to show, but there are two things here. One, there is a figure with 4 axes. And again, that's what I mean by figure with like the whole picture that's being output. And then the second element in our tuple is actually this. It's an array of 4 axes. So if I were to do like, let's see, fa equals to plot.subplots 2. So again, we output this, and let me just make a few more cells. F is this part, which yeah, F is the figure. If we look at A is this array of 4. So when you do axes is basically an array of each of your plots. If anyone remembers in the pre-work, there was one lab where you had to like define the like which row or which column you're editing on your graph. And then they had you like have some weird like modulo like floor division formula. That formula is actually to help you iterate through a 2-dimensional array. So there are easier ways to go about this. If let's say I wanted to hit this first graph, I would do A0 because it would be like the first row and then 0 again. So if I do A00, you can see that this is an axis. If I do A00.hist, and let's say I just add like a cardf, and what do I want to add? Maybe I do like miles per gallon, for example. I do that. And then if I output F again, you see that this has added a histogram to the first one. So hopefully that helps to like illuminate what's going on when you have axes. It's basically an array. And then the way that you edit each one, you can do it individually. When you have a lot of subplots, you would do it in a loop. So that's why I think if anyone remembers, I think it's like different countries. I forget exactly what the context of that lab was. But when you have like a lot of subplots, it doesn't make sense to do every single one individually, which is why you have to come up with a loop to figure out how to iterate through a 2D array. And so that's why that was very complicated. I will say very, very unlikely a very, very large figure with like more than 20 subplots is going to be useful, just because, you know, each one's going to be very small. You would have to like point to the specific one that you want to look at. Sometimes it's more helpful to just, you know, have individual ones. It might be clearer that way. But yeah, I think it's important to understand the structure of these subplots. So main things I want you all to take away from this is, one, the unpacking of when you create subplots. You have the whole figure as one variable and axes, which is the array of each graph, as another variable. And then, yeah. Another thing I wanted to show you all, if I just do test equals to plot.subplots, 2, so let's just create a brand new one, completely empty again. Test will be my tuple of the figure and the axes. So if I accidentally don't want to deal with, if I don't want to deal with the unpacking, which I think you should deal with it just the way that you usually do it. But let's just say I wanted to edit this first graph and add a histogram there. You would first have to go into, you know, the second element of the tuple. So So I do 1. And then, oh, actually, let's try and edit this one here, this top right one. So it's in the first row, so 0, and then it's in the second column. So test 101 hist, and then this time let's do maybe, I don't know, let's do horsepower. RDF horsepower. I'm here. Cool. And then when I output test, oops, I want to output the figure, you can see that horsepower was added there. It gets a little bit confusing because you're basically updating a figure every time you update the axes. But yeah, that's, I think, something that is worth getting used to. All right, let's go through a more like full example here and a little bit easier to keep track of. Oh, before I move on, questions at this point?
Yeah, I have a question for when you did the test, the first, I know the 101, what's the first one signify?
That's a good question. So the first one signifies that we're, okay, so let me put test here. So the first one, this one here, is saying that, okay, the biggest data structure here is everything is in tuple. The first element of this tuple is here. The second element of my tuple is here. So the first one is just saying that, okay, I want to look into my axes, not the figure. And then the 0 is saying, okay, within the second element of my tuple, I'm looking at the first row. And then the 1 is looking at, all right, I want the right side one.
All right. I'm not, I don't know. It still doesn't make sense.
That's okay. This is not the usual way you do it. Usually you just do it this way. You just have F and A. And then in this case, each A is an array. So therefore, like if you can just index through A. So for example, if I knew I wanted to do this graph here, it would be A10 because it's the second row, first column. So
right.
This one is the one that you should care about more. This one is more of just showing that it unpacks it for you.
Oh, okay.
So, but no one, not no one, but people don't usually do this method. I just want to show that it's possible.
All right, thank you.
You're welcome. Okay, so let's just break down this example that I have here. What I wanted to point to here is that sometimes you have attributes that are related to the figure, and sometimes you have attributes that are related to each axis. So this is an example of one of them. So let's do it step by step again. Right, so I have this empty fig axis, and this time I just have 1 row, 2 columns. In this case, I wanted them to share the y-axis, just because. If you look into the subplots documentation, these are all the parameters that you can add. Maybe I want to like have it share, well, I only have 1 row, but you can have it share the x-axis. All these others, I don't think I've honestly used that much either. But anyways, the first thing I want to add is a title for the entire figure. And so that's why this subtitle, which I think stands for super title, but I'm not 100% sure, but subtitle, which is something I had to look up, works on the figure. And that's important to note because for all of these other things, I've been adding the histogram to like an axis. Actually, let me just get rid of this so it's less confusing. All right, so each of these I'm working on an axis. So just to know, this one you're working on a figure. So when I add this, the text, the subtitle is related to the entire figure, not a specific axis. Only later when I'm like adding, okay, let's say I'm like just adding the histograms for now. And I want to set like the X and Y labels. This will be done on each individual subplot. So I'm setting X label equals to weight, Y label equals to frequency, and same here. And these are going to be different, right? Because this one I want to label weight, this one I want to label year, And you can see here, I'm setting it on the specific axes. And then finally show. Something else that I wanted to show you all is that here I add the X and Y label under this set method, which is kind of annoying because previously when I just had a single figure, I set the X and Y label this way through plot.x label, plot.y label. That's kind of an annoying inconsistency. What you have to know is that when I'm doing something like this, there are no subplots, there are no axes. You're actually just plotting the graph straight onto the figure, which is why it's PLT dot. It's also why the methods are just different when you're working on a figure and working on an axis. The name of the method that does the same thing can be different, and X label, Y label is one of them. As an example, if I were to do it the same way as I did on top, if I try to do like axes 0 dot X label equal to weight, that actually didn't work. So if you see the X label doesn't have a label, sometimes it throws an error, sometimes it just doesn't work. So this is something that I also had to Google, like, why isn't it showing up on my subplot? Is because in a subplot, you set these things using a set method. Just something to be aware of. I think subplots are probably one of the more complicated things that you have to do in graphing. Again, I think when you're creating your graphs, sometimes, yes, we have our labs that tell you to create these like very gigantic subplots, but it's important, especially when we get to our projects, to think about, is this graph going to be useful? If it's maybe for your own exploration, then yeah, maybe a subplot with many subplots works because you are the one that's going to go through each one and just look at the distribution of something. But if you know that you're going to use this to like convince stakeholders of something, think about, are they going to find this useful, or are they going to want to look through it even? If you give them like, you know, a giant, like, I don't know, 7x7 grid of subplots. So keep that in mind as well. All right, so that's Matplotlib. I'm gonna talk really quickly about Seaborn. And Seaborn, this is the import statement, SNS. I don't know why it's SNS. But for some background, Seaborn was actually built on top of Matplotlib. So any Seaborn graph is actually a Matplotlib graph, but all of the methods within Seaborn already have set attributes to make a graph appear a certain way. Also in Seaborn, you have more complicated or more intricate graphs already built out. One example is a box plot. And I'm just going to run this really quickly. This is a box plot. Basically, if you have like, as an example, if you have like 9 different categories of data and you wanted to look at the distribution of the data within each category, a box plot is a really good one to look at. Basically, this is like minimum, maximum, the middle line is the mean, or sorry, median. And then the box shows the interquartile range, basically like the 25th and 75th percentile, and then any outliers. So box plots are usually pretty informative. Matplotlib doesn't have a box plot function, I think, or at least that's actually a good question. I'm curious right now. Matplotlib box plot. Maybe they do have one now. Oh, cool. They have one now, but they actually did not used to have a box plot box plot method. So you would actually have to manually create boxes and create like, you know, this boundary and this boundary. So Seaborn has made that a little bit easier. Also, if you take a look at the box plot documentation and code, I wonder if they have any examples. You can see that is a little bit not as nice, first of all, and you're setting things like this. So you have, again, your axes and subplots, you set title, and you have your plot here. Versus in Seaborn, it's a little bit more, what's the word? It's all in one line, basically. So you have your box plot here, and then you just set your X label, Y label on your box plot. And then when I run this again, that should be there. Hold on, let me just, there we go. And then I can just do, I think plot.show also works here. There we go. And plot.show works because Matplotlib is the backend of Seaborn. it's really a personal preference whether you like to use Matplotlib or Seaborn. People like, I would say more recent students like Seaborn more because the colors are nicer and a lot of the default styles are just nicer. Also fewer lines of code. But it's really up to you. I think that they are interchangeable. You can choose to, you know, play around with both of them. Maybe you want to focus in on one. But yeah, I've seen in the past year or so, most students like to use Seaborn. Questions about this? Seaborn, I don't have too much to add. Cool.
I had a quick question. Does Seaborn also have histograms or just mainly box plots?
Seaborn has everything. So Seaborn has what Matplotlib has and more. So I think if we do, let's see if I can do this off of memory, maybe car.df, and let's take a look at this weight. Okay, so let's look it up real quick. Seaborn histogram. Oh, it's called Histplot. That's another thing to look out for. Not Histplot. Oh, another good thing about Seaborn that I should have mentioned is that Seaborn works nicely with data frames. So one thing that you can do here, I also want to figure out why there's no Histplot. Let me just, I think I might have an outdated version of. Okay, let's try distplot. But anyways, I think this is how you do it. Never mind. Basically, and I'm gonna figure this. Let me just figure this out real quick. There we go. This is what the histogram from Seaborn looks like. You can see that they also do like the what do you call that? Like the estimation of the distribution like that. Something here that I'm probably not going to try now is you can see here that you can actually input a data frame, which is pretty nice. So I'm not sure. Actually, I can try that with I think a different one would work better. So if I did like sns.scatterplot, and bear with me as I figure this out, sns.scatterplot. So I actually don't use Seaborn that much. As I mentioned, because when I was learning data science, Seaborn was not that fleshed out yet. It's another one, acceleration, I think. Is there no weight? Okay, let me just look at displacement real quick. And let's just check really quick. So you can have your data frame here, and then you can give it x equals to what, y equals what. Maybe that's what I have to do. There we go. Okay, never mind. Maybe like this. Oh, there we go. Nice. Okay. So one pretty neat thing about Seaborn is it actually interacts with data frames automatically. So here I just tell it the data is going to come from this data frame, and then the x-axis just pull from here, y-axis pull from here, versus, you know, doing like car.df, displacement, car.df, acceleration. Really up to you which one you want to use. But yeah, and then you can go on and like add, I think it's title equals like relationship between blah, blah, blah. Okay, maybe it's not title. But yep, I forget what it is exactly. But yeah, you would just look it up on how to do that.
Thank you.
Yeah. Mm-hmm. So yeah, that's Seaborn. Not the one that I usually use, only because when I was learning it, Seaborn wasn't very fleshed out. So a lot of students like it, but I'm just, as you can see, less used to using it. All right, so that's Seaborn. The one that I wanted to share with you all that is not part of the curriculum, but I think is a cool one to know, is Plotly. So Plotly, for a little bit of background, is built off of this JavaScript library known as D3. So if anyone's heard of D3, or if you haven't heard of D3, D3 is one of the biggest libraries for doing visualizations just in the coding world in general, but it's built in JavaScript. And JavaScript, if anyone has seen JavaScript, not as user-friendly in my opinion, but Plotly is built off of that. And things I like about Plotly is they also more recently came out with Plotly Express that has made it a lot easier to create graphs as well. I also like their documentation a lot more because this is their scatter plot documentation. I just think it's clearer and easier to read. It's more consistent. I know it sounds like I'm a little bit biased here, but if I look at Plotly scatter plots, they have a lot of examples as well. So you can see here, they have a lot of examples. They show you what it'll look like. And there's a lot of like customization that you can do. Why I think that Plotly is a good one to learn is because later on, so it's not officially part of our curriculum, but usually towards the capstone, you get, we as instructors do a lot of like extra things that you can incorporate in future projects. One of the things is dashboards. And Plotly does have a good dashboarding library. And Plotly is just good to know because when you're creating these dashboards, you can just copy and paste your Plotly code into the dashboard. So as a really quick example of what Plotly looks like and why I like it so much, let's just plot a scatter plot of miles per gallon and displacement. Usually doesn't take this long. So I'm curious to what's going on. Okay. What's really nice about this one, I think it's nicer. Two, it's also interactive. I'm really trying to sell Plotly here. But things I like about it, it also interacts well with the data frame. So similar to what we were doing with Seaborn, I told it, okay, look at CarDF, X is displacement, Y is miles per gallon. The title, it's just, I think, more intuitive that it's just title equals to what. You can also, because it's interactive, you can introduce data, the hover data. So for example, I say that, all right, when I hover over a point, I also want to see the car name and the model year. So if I hover over this point, you can see that this is like that Oldsmobile Cutlass Sierra model year 82. So sometimes useful. And then also I was able to add this trend line here. Yeah, I was able to add the trend line. We'll talk about what trend lines mean in phase 2. So I personally use Plotly for most of my graphs just because I like how it looks. But honestly, it doesn't matter which one you use. I think for now, my advice is just to be consistent with which Plotly library that you're using, just so you get used to it, and then it's just faster when you want to create specific graphs. But yeah, let me see. I don't think there's anything else in this notebook. Does anyone have any questions regarding visualizations? Okay. So now that we've talked about visualizations, when it comes to like the either topic 4 or 5 mini project, I mean, you can also do this as well. Those mini projects in the solutions, I believe, or is a possibility to use like the Pandas built-in visualizations. That's another thing that exists. So I think if you do like Pandas has its own visualization functionality. So I think if I do like car DF miles per gallon dot plot, I think that will plot it for me as well. And if I do like kind equals, I think if I do kind his, it does that for you. And this is actually Pandas calling on Matplotlib functions. So if you that's just something that's good to know. If you just want a very quick visualization, you can also use the Pandas built-in one, which calls on Matplotlib functions automatically. As you're going through the mini projects, I think it's a good idea to just, practice doing visualizations. If not practice visualization, practice looking up how to get the visualization that you want. It's going to be a lot of reading through documentation, a lot of Googling, a lot of Stack Overflow. That's part of the process. So in the one-on-ones that are coming up, I hope to see, and of course, if you don't have any other questions, I hope to look at one of the mini projects. I think that's like it's a good litmus test for how comfortable you are with going through like a narrative of data cleaning and also a little bit of EDA, exploratory data analysis. All right, well, any other questions? And we're a little bit early as well. Any other questions before we close out? All right, well, the next time we're meeting is going to be next Tuesday. So next week at this time as well. We're going to be talking about database types or like data, SQL and like non-SQL stuff like that. I will say that for the end of phase project, if you just stop here with the material, you can do the end of phase project. So if anyone's interested, we do have like an entire week. So if you want to just, focus more on this material, maybe look at the phase project to figure out what you want to brush up on, feel free to do that. But yeah, topics 7, 8, 9, 10, they don't have to be incorporated into the project. They are optional to incorporate. It would be cool to, but you don't have to. And I'll talk about what are the ways that you can incorporate them if you want to. All right, well, that's all from me. Any final questions? All right, then, if there's nothing else, I will see you all at your one-on-ones or next week. As usual, any questions you have, feel free to Slack me and let me know. All right, have a good rest of your week, everybody.
Okay.
Bye.
See you guys.
Bye. I'll see you in a
Bye,
bit.
everybody.
Bye.